friends, this is Rajeshri Patil and I am going to share some information about proximity sensors. These are the sensors which are able to detect the presence of nearby objects without any physical contact. A proximity sensor often emits an electromagnetic field or a beam of electromagnetic radiation, and it looks for the changes in the field or return signal. These sensors are commonly used in smartphones to detect accidental touchscreen taps when it is held near to the ear during the call. They are also used in a machine variation monitoring to measure the variation in a distance between a shaft and its supporting bearing. Now the classification of the proximity sensors is proximity sensor is basically divided into 4 types: inductive, capacitive, ultrasonic and optical. Further, optical is divided into reflective and through beam, and reflective into 3 types such as direct, retroreflective and a polarized reflection with reflector. First of all, inductive proximity sensor. An inductive proximity sensor is an electronic proximity sensor which detect a metallic object without touching them. Their operating principle is based on a coil and a high-frequency oscillator that creates a field in the closed surrounding of the sensing surface. The operating distance of the sensor depends on the coil's size as well as the target's shape, size and material. Now the construction and working of the inductive proximity sensor is: the main components are coil, oscillator, detector and the output circuit. The operating distance of the sensor depends on the actuator's shape and size, and it is strictly depend on the nature of the material. The coil generates the high frequency magnetic field in front of the face, and when the metallic target comes in this metallic field, it absorbs some of its energy. Hence the oscillator field is affected, and the rise or fall of such oscillation is defined by a threshold circuit that changes the output of the sensor. Now the capacitive proximity sensor. The capacitive sensors are used in non-contact detection of the metallic object and non-metallic objects. The capacitive proximity sensor uses the variation of the capacitance between the sensor and the object being detected. The capacitance methods are very sensitive, and distance down to 1 microinch can also be measured. The main component of the capacitive proximity sensors are plate, oscillator, threshold detector and the output circuit. The plate inside the sensor acts as one plate of the capacitor and the target acts as another plate. The air between them acts as the dielectric between the plates. The capacitive sensor can detect any targets whose dielectric constant is more than the air. As the objects come close to the plate of the capacitor, the capacitance increases, and as the objects move away, the capacitance decreases. An electronic circuit inside the sensor begins to oscillate. The rise or the fall such oscillation is identified by the threshold circuit and based on the output switches. Now the ultrasonic proximity sensor. The ultrasonic proximity sensor are some type used in the place of the optical sensors. Instead of using a light beam, a high frequency sound wave is used. This sound wave is above normal hearing frequencies, approximately up to 40 kHz. The ultrasonic sensor can measure distances in centimeters and inches. It provides a good readings in sensing large-sized objects with hard surfaces. The ultrasonic sensor sends out sound and receives it back using the receiver. Together, the ultrasonic sensor, sender and receiver look like a pair of eyes but it's not a sight sensor. Instead, those eyes are really more like a speaker and a microphone. Now the optical proximity sensor. A proximity sensor of the object is detected by the action of the traveling light move. These sensors use light-sensitive elements to detect objects and are made up of a transmitter and a receiver. The object within the range of the sensor can detect the presence. The light emitted by the transmitter focuses on the object which reflects to be received by the receiver photodiode. The reflected waves travel back and received by the solid-state photodiode through the receiver lens. This is the working of the optical proximity sensor. Now the conclusion from this presentation is the machine tools, woodworking machines, packaging machines and other types of machineries. These proximity sensors are used. Again, the further applications are automatic door units such as garage doors or doors inside buildings, elevator doors or doors inside railway coaches. Also, these proximity sensors are used. The building and automotive sector are further industries using high volumes of proximity sensor. In all of these applications, proximity sensors are very useful. Thank you.